In this video, we're going to cover natural log differentiation. So we have a function f of x is equal to natural log of the square root of x minus 1, and we're trying to find the derivative of this. So in order to do this, we have to recall one property of logarithmic functions. So remember, hopefully you learned this in like math 2 or like algebra or like whenever you learned this, hopefully before calculus. Remember that excuse me, we have a function, a logarithmic function log a to the b. We can pull out this exponent and place it to the front, so we have b log a. So these are equivalent. So how are we going to use this in this problem? First of all, we're going to rewrite this function as ln x minus 1 to the 1/2, because anything to the square root is just anything to the 1/2 power. And then using that property, we're going to put this out to the front. So we have f of x is equal to 1/2 natural log of x minus 1. And then we can derive as normal. So hopefully at this point, you know how to, if you're dealing with functions like this, if you're trying to find the derivative of functions like this, hopefully you know that the derivative of natural log is just 1 over x, and you also know how to use chain rule. So if you don't know how to do that, that's okay, but these problems might be out of your skill set for now. So continuing on with this, this constant is going to be left out. So we have 1 over x minus 1 times 1. That's the derivative of this function using chain rule. So f prime of x, or the derivative of f of x, is equal to 1 over 2x minus 1. So yeah, that's basically what you do. The step-by-step process of this, of deriving equations like this, is usually to find or rewrite this equation using properties of logs, and then you can just make it easier for yourself to derive something. So let's move on to a question that's a little more harder, but hopefully you should know. So same thing. We have a function, natural log of x over x plus 1, and we're trying to find the derivative. So we can use another property of logs. If we have log a over b, that's equal to log a minus log b. So therefore we can rewrite this expression as ln of x minus ln of x plus 1, and then we can derive. So you have f prime of x is equal to 1 over x minus 1 over x plus 1 times 1, which is just equal to f prime of x is equal to 1 over x minus 1 over x plus 1. You can condense it down if you want to. You're probably going to have to condense it down for the MCQ, but if you're lazy or you're doing the FRQ, there's no need to simplify. So you can just leave it as this if you want. Let's move on to something a little more harder. I don't know why I said it like that. Move on to something a little more harder. So, oops, I don't know why I keep doing that. So now, same thing again. function is ln of x times x squared plus 1 to the x squared plus 1 to the second, or x squared plus 1 squared. I don't know why I said to the second. And that's all over root 2x squared minus 1. So hopefully you also remember this property of logs. So if we have log a times b, that's just equal to log a plus log b. So using this property of log, we're going to use all three of the properties of logs that we just learned or just remembered. We can rewrite this entire expression as, I'll do it here because it's probably going to take up a lot of space. We can rewrite this expression as ln x plus, since these are multiplied, plus ln of x squared plus 1 squared minus, because we're dividing here, natural log of 2x squared minus 1. And then we can use our, let me draw the circle better. We can use our exponent rules to bring this exponent down. So we have f of x is equal to natural log of x plus 2 natural log of x squared plus 1 minus, this is the same thing as 2x squared minus 1 to the 1/2. So let me write that. This is the same as 2x squared minus 1 to the 1/2. So we can bring, oh my goodness, we can bring this exponent to the front. So you have 1/2 natural log of 2x squared minus 1. And then at this point we can differentiate. Let me scroll down so we have a little bit more space. So we can take the derivative of all this. We have 1 over x. Derivative of this is 1 over x squared plus 1 times 2x. Then derivative of this is let's see, 1 over 2x squared minus 1 times 4x. And then I guess you can technically leave this as is if you want, but I'm just going to condense it down a little further. So we have f prime of x is equal to 1 over x plus 4x x squared plus 1 minus, these are going to cancel out. So we have 2x, 2x squared minus 1. And there we go. Okay, now let's get even harder with this next question. So now we're trying to do the same thing. We have this function, roots x squared minus 1 over x squared plus 1, and we're trying to find the derivative. But you might be confused right now because you don't even see a natural log or any log for that matter. So if you have this weirdo function like this, the entire point of learning logarithmic differentiation is that it's a cool way to differentiate these weird functions like this. So what do I mean by that? Okay, well, first of all, let's rewrite f of x as y, so it's just a little easier. So that means technically we're finding y prime. Finding y prime. So how are we going to use natural logs to differentiate this if we don't even have natural logs in this entire equation? Well, first step is to introduce a natural log. So we can take the natural log of both sides to introduce a natural log, and this is a clever algebraic thing to do because these are still equivalent. And then we can use our properties of logs to rewrite this right side of the equation. This side of the equation. So going up here, we can rewrite this as natural log of x squared minus 1, x squared plus 1. Okay, this is a little messy, but you get the idea. We can rewrite the square root as this function, or these things, to 1/2. And then we can drag this out to the front. So you have natural log. Let me rewrite that y better. You have natural log of y is equal to 1/2 natural log of x squared minus 1, x squared plus 1. And then we can use properties of logs again to rewrite this little section. So we're dividing here, so we can rewrite this as 1/2 natural log of x squared minus 1 minus natural log of x squared plus 1. And then at this point, we can derive. You are going to have to use implicit differentiation. It's an easy implicit differentiation, but hopefully you should know what implicit differentiation is. So the derivative of ln y is 1 over y times y prime. And then the derivative of ln x squared minus 1 is 1 over x squared minus 1 times 2x minus the derivative of ln x squared plus 1, which is 1 over x squared plus 1 times 2x. And then if you multiply all this out, these cancel out. So we're left with 1 over y times y prime is equal to x squared minus 1 minus x squared plus 1. Let me see if I'm doing this correctly. Yep, okay. And then now that we have this, to isolate y prime, we can multiply both sides by y. So if we multiply both sides by y, we have y prime is equal to y x squared minus 1 minus x squared plus 1. This is getting a little weird. Let me reorganize this a little. Yeah. And then we're basically done. But I mean, this is technically correct, but you're gonna want this in terms of x. But how are we gonna get this in terms of x with this y here? Well, recalling our original statement, we know that y is equal to, right here, we know that y is equal to root x squared minus 1 over x squared plus 1. So we can just substitute that back in. So we have y prime, y prime roots x squared minus 1. Let me write this better. X squared minus 1, x squared plus 1. All this multiplied by x squared minus 1 minus x squared plus 1. And there's your answer. Okay, let's move on to our final problem. Wherever that is. There we go. So we're gonna do a similar thing that we did last problem. So same thing we've been doing this entire time. We have a function, roots x minus 1, x minus 1 times root x minus 2 times, or excuse me, f of x is equal to roots x minus 1 times x minus 2 times x minus 3, and we're trying to find the derivative. So first step, rewrite this f of x as y, so it's just easier. And then we're going to take the natural log of both sides. And then we're going to rewrite this square roots as this thing to the 1/2 power. So we have x minus 1, x minus 2, x minus 3 to the 1/2. We have this exponent here, so we can slam this all the way to the front. So you have natural log of y is equal to 1/2 natural log of this entire thing. And then we can use properties, the product property of logs. So you have natural log of y is equal to 1/2 natural log of x minus 1 plus natural log x minus 2 plus natural log x minus 3. And then we can derive. So implicit differentiation, we have 1 over y times y prime. And then we differentiate all these terms. So we have 1 over x minus 1. This is multiplied by 1, so we can just leave it as that. Then we have 1 over x minus 2 plus 1 over x minus 3. And then we can multiply both sides by y. We have y prime is equal to y over 2, 1 over x minus 1, 1 over x minus 2, 1 over x minus 3. Let's go over here. And then we can substitute back in y to get this in terms of x. So here's our y. There's our y. So we can just substitute that back in. So we have roots x minus 1, x minus 2, x minus 3. This entire thing is over 2. Let me scroll a little bit to get some more space. And then we have 1 over x minus 1 plus 1 over x minus 2 plus 1 over x minus 3. And there's your answer. So yeah, when I was first learning this, I struggled a little bit, but if you just get your properties of logs down and you know how to comfortably derive natural log functions using chain rule or whatever, you'll be fine. You'll be fine. You notice that it's a very formulaic process for these questions that already have a natural log in them. For these kinds of questions, you literally just rewrite. The goal is to rewrite this expression on the right so that you have an expression that you can derive easily because it's separated into multiple terms. And then for questions like these, you just take the natural log of both sides, rewrite the right side of the expression, and then derive. Or, yeah. Derive both sides and then multiply by y and then sub in y. So yeah, it's a very formulaic process. With enough practice, you should be able to do this, as with anything.